Welcome to Talking Industrial Automation, a podcast where you get to know the people who make modern industrial automation possible. You'll get to hear from CSIA system integrators and industry partners to get a better understanding of how they help their clients solve process challenges and how they earn success in their careers. Along the way, we'll touch on system integration best practices, technology, trends, and challenges. Whether you are a manufacturer, end user, supplier, or system integrator, you will enjoy the insights CSIA members bring to this podcast. Let's get started. Hi, my name is Lisa Richter, the host of Talking Industrial Automation, a podcast where you get to know the people who make modern industrial automation and processing possible. In today's episode, we're talking industrial automation with Rick Kaun, who is VP of Solutions for Verve Industrial Protection, an ICS security provider of both software and services. For almost 20 years, Rick has traveled the world to work with clients of all sizes and in multiple industry verticals in his roles at Matricon, Honeywell, and now Verve. He always strives to work with his clients to find scalable, affordable, sustainable solutions in pursuit of the balance between security and operations. Rick, welcome to the podcast. Why don't you start by talking a little bit about cybersecurity in general? You know, what does it mean and why is it unique in a control system or operational environment?
Well, thank you for the opportunity to share with your audience. I love this topic, so I'll happily jump on the podium anytime. But yeah, cybersecurity and OT gets a lot of airtime, gets a lot of content, gets a lot of buzz, and there's some questions about why it's so hard or when you go to start, where to start. So we're quite excited to share our insight. It's kind of scary, but also reassuring that every time I go on the trade show circuit, I've been doing this for almost 20 years, some of the basic concepts that we're sharing are still being adopted or people are eagerly writing them down, which scares me that we haven't seemed to make progress. But the difference is a lot of people have, and they're starting to realize some of the challenges, which we'll hopefully share today. Really, the end game for anyone listening with security is not necessarily hard and crunchy on the outside or protect against hackers, although that is a component. It's about the safe, reliable, expected operation of your facility. And we often find that even if there is an incident in an OT environment, we don't necessarily worry about whether or not it's cyber because, I mean, really an operational environment, it's get it back up and running, get a safety net, make sure we're on spec and on safety. So really, if we turn security practices and principles into always an eye towards safe, reliable, expected uptime and performance, we'll do pretty well. The thing I want to make sure we weave into this discussion today, and part of why I highlight in a bio that we try to look for scalable and affordable solutions, is that this is a program. This isn't a one-time investment. This isn't a project. We throw some technology out there and we put it behind us and move on to something else. We need to be adopting this as a program. We need to have a lot of care and feeding. We have to have an eye towards the future. And it can be complex unless you break it down into complementary steps and tools. So hopefully by the end of today, we'll have a really good understanding as to how some of those go together and some considerations you need to take during the process and along the way.
Given the challenges you highlight, surely there must be some guidelines or standards our audience can follow. Can you speak a bit to those? And more importantly, are there any key components to those standards that are significant either because they're hard to deploy or because they are critical to other aspects of a security program?
Great question. And yes, there's no shortage of guideline. And every time we go in somewhere, somebody always asks me, well, should I do this one or that one? Which one do you recommend? And I hate to say you pick because you do want to give some guidance. But the reality is that there's similarities in all of them, which is what draws towards the building blocks. Three of the big ones that you've probably heard the most, one would be NERC-CIP in North America, NERC-CIP being a regulatory for power. Coming out of the 2001 power outage, there were all sorts of regulations put on the power industry. In fact, there were 80. They were all around reliability and uptime, only one of which was the cyber standard. But when you unpack the cyber standard, it's now onto, I can't even count which version, 7 or 8 iterations in, there's actually over 170 sub-controls in that one cybersecurity, right? So there's a lot to digest there. And the knock against NERC is that sometimes it's more compliance-based and not really security. You can be compliant but not secure. So it's a good framework. It's got the same basic principles and guiding intentions that the authors created or started with, but maybe it's not seen as strict a control for pure security per se. Which brings me to the other two. Well, I'm going to introduce three actually. There's the ISA 99, which is also known as the IEC 62443. It's sort of the godfather. It's got a whole bunch of heavyweights and engineers in this space from around the world. Some of the big names in ICS security really have been helping for years to drive it. It's very engineering. It's very well thought out. It takes forever for them to agree on nomenclature. So you know that it's very solid when it's done. The challenge I have with it is that it's a little less than prescriptive. It says you should do this, you should have these concepts. It introduces the Purdue model of zones and conduits. Very good basic foundational stuff and good solid engineering documentation. They are still, however, developing more and more standards, and so it's not a complete guideline yet, per se. The couple that I did want to talk about, though, NIST CSF. NIST is a National Institute of Standards and Technology. The CSF stands for Cybersecurity Framework. What NIST did was they took all these different initiatives from COBIT and ISO, et cetera, and they cross-mapped them into a master standard. So if you really want to see what you might have from a corporate or enterprise entity for some basic building blocks on your policies and procedures, NIST is a great way to see what you can already have and sort of pick off low-hanging fruit. The third one, though, that is the rapidly becoming the favorite, if you look at the SANS research from the last couple of years, the number one policy or guideline that organizations are following, and in fact, all the respondents had to write it in because it wasn't in their checklist, is the CSC20. And that's from the CIsecurity.org site. It was originally built by SANS. They've just gone to version 7. Version 7 breaks the 20 into, I believe it's 5 different, either 4 different of 5 each or 5 different of 4 each, but basically stages that you would go through as you mature over time. And the thing I really like about the CSC is it actually has measurements within the standards. So you can have a quantitative measure of how much you've completed. So for example, every single standard starts with some sort of inventory. So to your question about what are the underlying components, inventory is key because inventory drives all your other decisions. How many of these do we need to do? How many of that do we need to buy? Who owns this process, this asset, this class of system, et cetera? And the CSC20, for example, on the inventory will say the maturity level of 1 is you have an inventory. Maybe it's on a piece of paper, maybe it's an Excel spreadsheet, maybe you've got some ideas to ownership. But a level of 2 is that you have that inventory with some semblance of loop back to the assets to verify. And then level 3 would be real time, automatic updates, et cetera. So you can see how you don't need to boil the ocean right out of the gate and be an expert. You can grow over time. And so that's why I really like the CSC20.
Let's say we settle on a specific standard or program. What security tools are available and how do we pick?
Great question. If you were to do a search for cybersecurity tools on the internet, you would literally have thousands, probably tens of thousands of options. I even have a graphic that's just an eye chart. And it's a great question. People often, unfortunately, in this space say, okay, I'm going to look at the CSC standard or the NERC CIP, and there's very real specific controls. There's antivirus, there's endpoint protection, there's malware prevention, there's backups, there's change management, et cetera. And they go and they buy siloed tools. When I say siloed tools, I mean a tool that in and of itself probably does some things if you look at the IT marketing brochure, and it may or may not apply to some or maybe many of your assets in your facility. But what our audience is challenged with is that they've got a real, what I call east-west and a north-south coverage. East-west means what Honeywell says you can do or what Emerson says you can do, you can't necessarily do on the Yokogawa and vice versa. So selecting tools that have a wider footprint or that augment what the OEM is giving you is a significant challenge. The other one would be what I call north-south. So what you can do on an HMI or an engineering station that looks and feels a lot like an IT machine is very different from what you can do on Rockwell PLCs or endpoints, embedded equipment, Schweitzer relays, et cetera. One of the biggest things is understanding not just these siloed solutions, but understanding how I'm going to tie them together if I need to use more than one tool, and how I'm going to extend them both east-west and north-south if at all possible. We want to avoid one of our clients who unfortunately has 55 different control security tools, 7 of which are just patching tools. I cannot understand how a single organization could possibly get value from or be properly using 7 different patching tools. I guess what my takeaways would be is know what done looks like. So in other words, if the CSC20, you want to pick a maturity level of 2, you have a quantitative measure to achieve, and then you take that quantitative measure, look back at your asset list, and then make decisions around procedure and technology. The second thing that would be something very beneficial is looking at this in multiple phases. Don't think that this first pass at endpoint or patching or system management is the be-all and end-all. I had a client once say to me, I don't want to be first. I don't want to be last. I just want to get it done and put it behind me. Well, unfortunately, security is a program. not a project. And the third thing that people often underestimate is the care and feeding that goes into this program once it's done. If you don't have an eye towards maintenance, your systems will atrophy the minute you put them in. And spending all this time and effort, the project team high-fiving each other and going home and leaving it to the day-to-day people who haven't either had the training or the support or the bandwidth to keep it up is an incredible waste of time and money. We see it, unfortunately, more often than I'd like to.
What would you say is the single biggest mistake you've seen clients fall victim to?
The single biggest mistake is not having a comprehensive inventory and then using that to drive exactly where they want to get to. We have, for example, a client at the other end of the spectrum. What they did was they put in some of our technology, and I'm not trying to make this a product plug, but we use a technology-enabled assessment to be able to help them put empirical data into what they should do and where they should do it. So let's just unpack that for a minute. I go to an environment in the OT space, and people there may or may not have an idea as to what they have for inventory. Sometimes they're right, sometimes they're not. We had a client that was wrong by 592%. By the time we did a walk down, they had a 6-fold increase in IP addresses they weren't aware of. And let's pretend maybe they're not that bad. They have a fairly good idea. They're only 20 or 30% off. They probably still don't know exactly how many they have of what and how to handle it. And the other thing is, it's one thing to have a list on paper, or some of these, anomaly detection tools say, oh, I've got these devices that are communicating. Well, not all assets are created equal. So let's make sure we understand what asset is where and what is critical, because that's going to drive decisions. We can't do full protection on everything everywhere. So this client put in the technology. They're able to profile the systems, both embedded systems and operating system based, and they are able to extract empirical data. How many systems actually are compromised by various viruses? How many of those systems are considered critical from the metadata or tribal knowledge that we append to that record when the operator sits in front of our inventory and says, these are critical, these are redundant, what have you. You then layer in third-party information, national vulnerability database. Here's the actual risks and patches outstanding. Here's how far off from level you are for system hardening or best practice. Now I've got a score on each asset relative to its criticality to give me a plan, right? And if you don't have a plan, you run out and you pull the trigger on siloed solutions and you try to create a punch list of accomplishments, but none of it necessarily comes together to provide actually comprehensive coverage.
Let me ask the opposite question then. What have you seen that does work well, and how do clients achieve success?
Yeah, so building on the previous one, I can't say enough about the inventory. We've had clients change technology decisions. I'll give you an example. We had a client that thought they had their corporate standard on a backup solution. Once we actually put in the inventory to see what was supported by the various OEMs and what technology worked, we compared their current corporate standard for backup versus the new and emerging technology, and we put the numbers side by side. Again, back to the empirical, they were able to make an intelligent decision. They needed a fraction of the hardware. The licensing was a fraction of the cost. They were able to significantly improve or reduce their bandwidth consumption between the sites. They have a central storage, which is where they have a smaller specialized team to help and support and restore. And so in other words, they went from what was a very laborious, expensive, technically burdensome environment to a very, very cohesive and agile, centrally supported response. They changed their standard, but it was based on empirical evidence. So understanding that part of their plan was technology, but the people in the process and having a centralized special team to be able to scale across multiple sites instead of having to stand up shadow IT in all these environments was a huge, huge difference. So really, it was the inventory put into a planning and a multi-phased with a multi-year approach. And the other thing that they were looking towards in that central environment was the aggregation of data. All these different systems put up valuable data. If you have to pivot between 16 different logins, or in the case of our other client, 55 different tools to paint an image of an asset, you're going to have a challenge. So we're seeing more draw towards a single asset-centric view with third-party data and metadata and tribal knowledge being brought in to give you that real triage of the asset itself. How do you automate and manage safety? One of the things that, I touched upon a moment ago in the success for these clients was centralized support. One of the biggest challenges in this space is there's not enough people, period. Now you try and find people that have a combination of IT and OT experience, or at least know IT security, but have a healthy respect for the OT environment, or the other way around, who know the OT environment, have grown up in it, but have enough IT smarts. It's a very, very short list. Now, and no offense to my operational-based friends, but bringing a grad out of some cool tech school and saying, now you're going to go work in the middle of nowhere, and you're going to research third-party patches and applications to be compliant for this power company, they're going to say, no, thanks. They're going to go work in Nashville, and they're going to go work in, Silicon Valley. They're going to go work somewhere fun. So we need to be creative. We need to have a centralized team to be able to pull the data together. So that brings us to, okay, so the data is there now, what do we do? And one of the other things I want to make sure that clients think about is not just do I have the intel, but do I have the ability to act? So one of the things I push back on with some of these silver bullets and the market hype in the space is, and I've been around long enough, I've seen two waves of the silver bullet coming. New technology is going to solve everything. The first was whitelisting back in the day. You just lock everything down and don't ever have to worry again. Well, we've quickly proven that you need more security than that. We're starting to see the bloom come off the rose in the second wave, which is the anomaly detection. And I think one of the single biggest issues, never mind their technology versus others, the single biggest issue that's overlooked with something like that is alerting or awareness is only half the battle. If you look at the 5 categories for NIST, it's identify, protect, detect, respond, and recover. If identify is all you're doing and some sort of detection, how do you respond, react, recover, etc.? So building tools that allow you to take action, which is part of why this is a bit of a dichotomy, building tools and having ways to take action once the alert is done is the other half of the battle. So by anomaly detection, you have your SOC, your Security Operations Center, give you information that something's happening. You need to have the tools to go do something. The clients that we're seeing have the most success are putting a centralized team in with that visibility, okay? The or what I call a 360-degree view of the asset. And they're seeing threats. And what we call it is think globally, act locally. So what we do with that central team and that central intelligence is they can see when something's happening. They can triage and they can take action. They can use the agents that we're using on the systems in the field to give comprehensive inventory to also harden those systems, to deploy software, to apply patches, to lock things down. Now, how does that work to still balance safety? Let me walk you through a case study. We had a client that said, got a phone call on a Saturday afternoon from a central office saying, we want all of a foreign country's antivirus removed from all of our systems. Everybody should know who that is, but we won't name names. So what we did at the central location was we were able to use the inventory tool, comprehensive inventory around software, up to 1,200 characteristics. We can pull almost anything. We pulled all of the systems at each of 6 different physical locations in 4 different states, okay? Central headquarters. We pulled all the assets. We did a subset to show me which one of these have this antivirus program on them. And then what we did was we printed out a list for each of the sites, and we grabbed the additional data around the asset. So not only is it the name of the asset with its installation version of that software, but because we put metadata, we're able to tell them which rack room it was in, which owner needed to be notified perhaps, etc. So we put a very OT type of touch in this. And the local representative at the site was then given a very comprehensive and detailed list of where he needed to go. The next thing we did was that agent was sent a command to uninstall the software. But we set a flag that said, you need a person present at the console to accept this command. So we're doing a central aggregation, one person looking at 6 different sites and giving you a laser-focused list. And then when we push the button, an actual operational rep at the console of each of these devices to uninstall means we've taken the best of an automated and central vision, but have a very last mile hands-on touch for the OT side of things. We were able to uninstall and confirm uninstallation across 6 locations in 1 hour. 60 minutes at 6 different sites to remove almost 150 instances of software. I don't think there's a lot of case studies like that in the OT space that can hold up to that. And we have one client right now that's looking at how they're going to do patching on north of 12,000 assets at over 250 locations. You have to have that think global, act local, or you're just not going to be able to keep up.
That's a really interesting application of security. Do you have any other examples of where the principles you outlined above have helped a client to succeed?
Yeah, well, obviously the first one I was talking a little bit earlier about a client, a technology-based assessment. Just to walk through a little bit more of that, the client, by putting the data in and the inventory, they were able to tell a number of measures immediately. The first was whether their systems were hardened based on best practice and how far off they were. The second was how many viruses and patches were outstanding. The third was how at risk they were based on the National Vulnerability Database. They also were able to drive into dual-homed machines that had 2 subnets or 2 network cards. Once they saw those devices, they further profiled them. They found insecure software on them, like TeamViewer. So really, I guess what I'm advocating is that if you start from a strong basis of empirical data about your assets, real time, don't be afraid to touch them. Pull it into a central location. Your ability to pivot and get value is driven only by how much you put in and how creative you are with the filters. Too many people are trying, like I said, to just knock down the basic premise, go change some passwords, go apply some patches. They need to embrace this as an active program that can have continuous improvement if you have the data at your fingertips. So we've seen clients everywhere from NERC-CIP improvement to NIST CSF, more than doubling their scores on automation and visibility and reduction in downtime. And we have clients that are starting to put together empirical databases on how many hundreds and thousands of hours they're saving by having this data at their fingertips. The very fact that they can take, like I said, one client, 12,000 assets, 250 locations. When the US CERT comes out with a new alert on a particular firmware, Schneider or Schweitzer, they can instantly filter exactly how many they have and where they have it. That saves hundreds and thousands of hours over years that we can't possibly, begin to accurately quantify. One last little stat for you. We had a client look at this agent-based approach versus the scan-based for patching. The basic premise was the scan had to run a scan, then push the patches, then rescan, and then we discovered that it missed some. The total effort in hitting that network and that bandwidth was about an hour and a half, and they missed 25% of the critical patches. The agent-based approach, you instantly saw what was outstanding. 7 minutes to deploy with a confirmation. Done. 100% coverage in 7 minutes as opposed to 75% coverage in an hour and a half. I could go on and on, but really what I'm trying to implore, and again, it goes back to the intro, scalable, cost-effective, some sort of automation. And really, don't be afraid of some of the trends in this space. Everybody says, I can't put an agent on an OEM's box. The OEM puts all sorts of agents on there. It's your asset. You need to maintain it. Everyone's afraid of the cloud or central. You can do, like we said, think global, act local. We can have a combination of IT/OT. You can combine a small number of people with automated tools to get you much better coverage. These are the things that I really hope that the market continues to adopt. They're a bit slow to warm. Many people hate the term cloud. Cloud is really just someone else's computer. I mean, if you're taking it off-site and putting it at corporate headquarters, you're effectively using an enterprise cloud anyway. So let's not worry about the FUD. Let's not worry about the silver bullet hype. Let's get down to brass tacks and build a program.
If people are interested to learn more about cybersecurity in OT and the methods, tools, technologies to put a program together, where should they go?
There are some really good ones and there are some really expensive ones, and you get different things from both. When I say expensive, I mean they charge a little more for the audience, and these are trade shows and different industry bodies. I'm going to walk through brands. So there's the pay for play, there's the free ones, and then there's the government-funded initiatives. So the pay for play, there's some really big ones. S4 is a really popular one. Dale Peterson does a lot there. It is becoming more, the people that are on the main stage are the vendors that usually pay more money. There's also some really good researchers in there as well. So he tries to balance it. It's a pretty good one. It's every January. It's not cheap. It's in Miami Beach, and the attendance fees is up there. But you get some real quality, technical, and evolving and emerging research. So those are good ones. There's a couple others like that, CS4CA. There's industry-specific ones. There's a lot of oil and gas specific or power. GridSecCon is the NERC funded one. It's not as expensive for end users. They're very good at keeping people somewhat to bay, which is maybe now switching to the free ones. In Canada, there's one called Public Safety Canada. They do one show a year, but they also do multiple trainings. The show this year is in the East Coast in Prince Edward Island in May. I'm on the committee. I want to make sure it works, so let's make sure we get some people there. The other free one that we get a lot of benefit or see a lot of newcomers to the topic come and learn would be the U.S. government's funded, the ICSJWG. And we can certainly append some links to these once the podcast gets launched. The ICSJWG is government funded. They don't take any money. Vendors can't buy their way onto the podium. There are vendor booths and there are presentations, often from academia and research, but also from case studies. Those are usually the ones because they don't have a way to filter other than it being of value. They try to filter out all commercial stuff and really push on vendor or end user cases and case studies. So those are good ones. And then two other ones to keep an eye on that are government funded and are being done in labs. So pure, propeller head fun geek guys playing with things. There's a manufacturing one based in Chicago. They've just rebranded to MXD, which is manufacturing meets digital, I guess. It's based right in Chicago. We're heavily involved in that one. There's a huge initiative to basically scale tools like this or others that can be centralized as a web-based source or commodity. If you look at the manufacturing sector, thousands of mom and pops that are too small to have a full IT department or technology. So to get cloud-based stuff that could be on a subscription really helps. And also to measure or benchmark themselves against their peers. So really a measurement or quantitative. And then the other one is being run by the Johns Hopkins Applied Research Lab University. And it's part of the Mosaic program. Mosaic is a huge government and military funded effort to look at real-time alerts. And as the alerts come in for something happening, to build what are called playbooks. Playbook would basically take action on your behalf. So actually seeing an emerging attack happen and shutting down a firewall port or a system if that's supportable in the OT space. So there's lots from paid to free to research. Happy to send you some links to share in posting. Or any of your readers want to ask, let me know. I go to these all the time. I did 19 shows last year in 24 weeks. So I know a few of the players and where they are and which ones are less or more money. So it's also a regional thing if some of your readers want to know where something close to them might be.
Those are some really great tips, Rick. Thank you. Well, that's it for today's episode of Talking Industrial Automation. Thanks for listening, and thank you, Rick, for joining me today.
Thank you for the opportunity. It's my favorite topic. I'm glad we had to stop at half an hour because otherwise I go all day.
If you enjoy this podcast, please subscribe in iTunes, Stitcher, Google Play, or wherever you listen to podcasts. You can also help others find us by sharing your favorite episodes with colleagues. Thanks for listening to the Talking Industrial Automation podcast. Thanks also to bensound.com for the music bumpers. Until next time.